Welcome to another lecture video for Math 171 Pre-Calculus Algebra. In this video, we're going to talk about Newton's law of cooling and the application of that. So the formula that our book gives is T equals C plus T0 minus C times e to the kt. Your C is equal to the temperature of the surroundings, and T0 is the initial temperature of the object. So whether the object be the turkey that you put in the oven at Thanksgiving, or the object is maybe a cup of coffee that you're letting cool off, or something like that. So the example that I have here talks about a cup of tea with an initial temperature, so T0, of 102 degrees Fahrenheit. And that's going to be placed in a freezer with a temperature of 0 degrees Fahrenheit. So, temperature of the surroundings is going to be 0 Fahrenheit. Now, after 5 minutes, the temperature is going to be 66.7 degrees Fahrenheit. I am so used to, when I draw that circle up there, it being a percent sign rather than degrees. And now I want to know after how long will it take for the tea to cool to 26 degrees Fahrenheit. And if you've taken any physics classes dealing with calorimetry or anything like that, specific heat, we're going to ignore the amount of cooling that is required for an object to freeze. So we're going to assume that this is actually a constant rate, which wouldn't really apply here. Newton's law of cooling requires that you keep the same state of matter, but so we've got a couple of things we've got to deal with here. The first one being, we're given that initial temperature of the surroundings, then temperature 5 minutes later. So we're going to plug all of those in order to figure out what K is, which is just a constant. So we get 66.7 is equal to temperature of the surroundings, which I called TS here. I should have called, being consistent with what the book uses, C. At any rate, that's 0 in this case. And then T0 is 102. Temperature of the surroundings is still 0. E to the k times 5, or 5k. Now I can simplify this to 66.7 equals 102 e to the 5k. Then divide both sides by 102, which I am just going to do literally. 66.7 divided by 102 is equal to e to the 5k. Take the natural log of both sides. So ln of 66.7 over 102 is equal to 5k. And then I am still leaving this literal, but I'm going to go in after this and punch it into the calculator. Divide both sides by 5. And that's going to be our k, which is approximately equal to 66.7. Natural log of 66.7 divided by 102. And then the whole thing divided by 5. So k is approximately negative 0.0850, which I'll just leave as 0.085. So now we want to know how long it's going to take for the tea to cool to 26 degrees. So let's plug in what we know to the formula. We know we're looking for 26. We still know the temperature of the surroundings is 0, which I'm going to take the liberty of just not writing it all here. We know the initial temperature is 102. Temperature of the surroundings is still 0. 102 minus 0 is 102. E, then we know our K is minus 0.085. And T is what we're trying to find out here. So we'll divide both sides by the 102. And get 26 divided by 102 is equal to e to the minus 0.085t. And take the natural log of both sides. And then divide both sides by 0.085. Or negative 0.085, rather. And that is approximately equal to natural log of 26 divided by 102, then divided by minus 0.085. And I get that T is about 16 minutes. So it'll take about 16 minutes for the tea to cool to that temperature. So now the problem that I have for you is going to be dealing with a Thanksgiving turkey, and these numbers may turn out to be completely unrealistic. So a 40-degree Fahrenheit turkey is placed in a 350-degree Fahrenheit oven. After 20 minutes, the turkey is 75 degrees Fahrenheit. If the turkey is done when the temperature reaches 165 degrees, how long will the turkey need to cook? So, again, for my 8 o'clock class, you will need to write up your solution to this and then email it to me. If you're in my 10 o'clock, you can also feel free to send it to me, but it's not required of you. And that is the last lecture video that we have. So I will see you in whatever environment I will be seeing your class in on Monday.